You skipped breakfast this morning, maybe lunch too. By the time dinner came around, you didn't just eat. You attacked the plate. You went back for seconds you didn't need, and somewhere around the third helping, a small voice in your head asked why you couldn't just stop. But the real answer is far stranger than willpower. Your body wasn't reacting to today. It was reacting to a famine that ended 11,000 years ago. You live in a world of grocery stores open 24 hours a day. You live in a world where food arrives at your door in under 30 minutes. And yet your body still behaves like scarcity could return at any moment. It hoards fat, it craves sugar. It panics at the first sign of an empty stomach. Why would a species living in abundance still be wired for famine? The answer starts almost 2 million years ago, long before agriculture, long before stored grain, long before anyone had ever seen a refrigerator. For most of human history, food was not guaranteed. It was hunted. It was gathered. It disappeared for weeks at a time when the rains didn't come or the herds moved on. A body that burned through its fat reserves the moment it found them was a body that starved the next time the land went quiet. So evolution built something else instead. It built a body that hoards. Anthropologist Richard Wrangham has spent decades studying the diets of early hominins, and his research points to a period of relentless caloric uncertainty. Early humans didn't eat 3 meals a day on a predictable schedule. They ate when food was available, sometimes in huge quantities, and then went without for days. A feast today had to carry the body through a famine tomorrow. This wasn't a lifestyle choice. It was survival math. Your ancestors who could store fat efficiently during a feast lived longer through the famine that inevitably followed. Your ancestors who burned through every calorie the moment they got it did not. Over hundreds of thousands of generations, that single difference decided who passed on their genes and who didn't. You are not descended from the efficient eaters. You are descended from the hoarders. This idea has a name in modern genetics. It's called the thrifty gene hypothesis, first proposed by geneticist James Neal in 1962. Neal was trying to explain something that didn't make sense in a world of grocery stores. Why do humans get diabetes and obesity at such alarming rates when neither condition seems to serve any purpose? His answer was unsettling. These conditions aren't malfunctions. They're leftover survival strategies. Genes that once kept famine-era humans alive are now working overtime in a world that never runs out of food. Neal wasn't looking at obesity in isolation. He was looking at populations that had experienced sudden shifts from traditional, feast-or-famine lifestyles into modern, food-abundant ones. Indigenous communities that had survived for centuries on unpredictable harvests, seasonal hunts, and long stretches of scarcity were, within a single generation of adopting Western diets, showing rates of diabetes far higher than the general population. The same genes that had kept their ancestors alive during hard winters were now, in a world of constant food, tipping their descendants toward metabolic disease. It wasn't a new problem, it was an old solution, applied to a world that no longer needed it. Think about what that means. The same biological programming that saved your ancestors from starving is the reason you can't walk past a bakery without your stomach tightening. It's the reason your brain lights up at the smell of something fried. It's the reason a single missed meal can make you irritable, distracted, almost desperate. Your body isn't broken, it's doing exactly what it was built to do. It just doesn't know the famine ended. There's a study that proves this in devastating detail. In 1944, physiologist Ansel Keys ran what's now known as the Minnesota Starvation Experiment. He took a group of healthy young men, all conscientious objectors who had volunteered for the study as an alternative form of wartime service, and cut their food intake roughly in half for 6 months, simulating the kind of famine conditions soldiers and civilians faced during World War II. What happened to these men wasn't just physical, it was psychological. They became obsessed with food. They talked about it constantly. They collected recipes they had no intention of cooking. Some hoarded utensils. Some snuck extra bites and felt crushing guilt afterward. Their moods darkened. Their concentration collapsed. A few even developed what researchers described as ritualistic eating behavior, stretching a single small meal across an hour, arranging food on the plate over and over before eating it. Their bodies had entered survival mode, and their minds followed without question. Here's the unsettling part. When the experiment ended and the men were allowed to eat freely again, many of them didn't stop at enough. They overate for months. Some described feeling unable to reach a point of fullness, no matter how much they consumed. Some gained back more weight than they'd lost in the first place, as if their bodies were determined to build a larger buffer against the next famine, just in case. Their bodies, having just survived a famine, were doing everything possible to make sure it never happened again. Sound familiar? This is the same mechanism behind modern dieting. You restrict your food intake, your body reads that restriction as danger, and the moment restriction ends, your body pushes back with cravings, slowed metabolism, and an overwhelming urge to eat more than you need. You call it a lack of discipline. Your biology calls it insurance. Now think about leptin, a hormone your fat cells release to tell your brain that you have enough energy stored. In a world of consistent abundance, leptin should be doing its job constantly, quietly signaling, "We're fine, no need to eat more." But researchers have found that chronic overeating and certain patterns of yo-yo dieting can actually disrupt this signal, a condition sometimes called leptin resistance. Your brain stops hearing the "we're fine" message. Instead, it hears something closer to famine, even while your body is carrying more stored energy than any hunter-gatherer ever had access to. It's a strange kind of miscommunication. Your fat cells are shouting that there's plenty. Your brain, still running ancient software, refuses to believe it. This is part of why so many people who lose significant weight find themselves fighting hunger for years afterward, not because they lack willpower, but because their brain is still reading a famine signal that their body's fat stores no longer support. This explains something else you've probably felt but never had words for. Why sugar and fat taste so undeniably good. In the environment your body evolved in, calorie-dense food was rare and valuable. A ripe fruit bursting with sugar, an animal fat rich in energy. These weren't indulgences. They were jackpots. Finding a beehive dripping with honey, or bringing down a large animal after days of tracking, meant survival for the group for days, sometimes weeks. So your brain built a reward system around them, releasing dopamine, the same neurochemical tied to pleasure and motivation, every time you found something calorie-dense. Today, that same reward system fires the moment you unwrap a candy bar. The jackpot your ancestors searched for across miles of savanna is sitting in a vending machine 10 feet from your desk. Your brain doesn't know the difference. It still treats every sugary, fatty bite like a rare and precious discovery, because for almost 2 million years it was. Food scientists have known this for decades, which is why so many processed foods are engineered to hit what researchers sometimes call the bliss point, the exact combination of sugar, fat, and salt that maximizes that ancient reward response. It isn't an accident that you can't eat just one. It's a design choice, built on top of a survival instinct that was never meant to be exploited this precisely. Even the way your body stores fat reflects this ancient logic. Fat isn't distributed randomly. Anthropological research into body composition across different populations has shown patterns that track closely with historical food availability. Populations that experienced repeated, severe famines over generations tend to show stronger fat storage responses today, a biological memory passed down through DNA. Your grandmother's hunger, in a very real sense, may still be shaping how your body responds to a skipped lunch. There is even evidence that famine can echo across generations in more direct ways. Researchers studying the children and grandchildren of survivors of the Dutch hunger winter, a severe famine that struck the Netherlands during the final months of World War II, found lasting differences in metabolism and disease risk among people who were never themselves exposed to famine at all. Something about the experience of extreme scarcity appears to leave a mark that outlasts the person who lived through it. Passed down through what scientists now study under the field of epigenetics, the study of how experience can influence which genes get switched on or off without changing the underlying DNA itself. Your body's relationship with food may be shaped not only by the eating patterns of your own life, but by the hunger your ancestors endured generations before you were born. And it isn't only about eating too much. It's about what your body does the moment food becomes scarce, even briefly. Skip a single meal, and your body releases cortisol, a stress hormone. Your blood sugar dips, and your brain, which runs almost entirely on glucose, sends out urgent signals. This isn't your body being dramatic. This is the same emergency system that once told a hunter-gatherer it was time to move, to search, to find food before the situation became critical. You feel it as hunger. Your ancestors felt it as a matter of life and death. Now place that ancient alarm system inside a modern environment. Researchers who study what's sometimes called the obesogenic environment point out that humans today are surrounded, almost constantly, by cues that trigger this survival response. Bright packaging, advertising, the smell of food piped deliberately into stores and restaurants. None of these cues existed for the vast majority of human history. Your ancient alarm system was built for a world with a handful of food triggers a day. It now fires dozens, sometimes hundreds of times, every single day, in a world engineered almost specifically to set it off. Here's the twist that changes everything. This system was never designed to be flexible. It has exactly two settings: abundance and famine. It doesn't understand, I'm trying to eat a bit less for health reasons. It doesn't understand, I'm intermittent fasting until noon. All it understands is whether food is coming in or not. And when it isn't, your body responds exactly the way it would if a drought had wiped out the herds 3,000 years ago. This is why so many people find long-term dietary restriction almost impossible to sustain. It isn't a failure of character. It's a fight against a system that has had 2 million years to perfect its response to scarcity, and about 70 years to encounter the reality of a world where scarcity, for many people, has essentially disappeared. 70 years is nothing in evolutionary time. Your DNA hasn't caught up. It may not catch up for thousands of years more. Researchers who study weight regulation have a term for this: metabolic adaptation. When you cut calories, your body doesn't just lose weight and stay quiet about it. It fights back. It lowers your resting metabolic rate, so you burn fewer calories doing the exact same activities you did before. It increases the hormones that drive hunger and lowers the ones that signal fullness. It makes you feel colder, more tired, more preoccupied with food. Also, you'll eat more and move less, both of which push you right back toward where you started. This isn't sabotage, it's protection. Your body genuinely believes it is helping you survive a famine, because as far as its ancient programming is concerned, that's exactly what's happening. This is also why crash diets so often fail in the long run, while people rarely talk about why. It isn't laziness undoing months of progress. It's a 2 million-year-old alarm system doing precisely what it was built to do, dragging you back toward the body weight it associates with survival. Some researchers call this a set point, a kind of internal thermostat for body weight that your brain fights to defend, sometimes for years after a diet has ended. Push too hard against that thermostat, and the pushback can be relentless. Even sleep gets caught in this ancient loop. Studies on sleep-deprived adults have found that a single night of poor sleep can shift the balance of ghrelin and leptin, the hormones that drive hunger and fullness, in a way that closely resembles the hormonal profile of mild starvation. Your body, sensing that something is wrong, that resources might be scarce, responds the only way it knows how. It makes you hungrier. It's not a coincidence that a rough night's sleep so often ends with you reaching for something sugary the next day. Your body isn't reading your calendar, it's reading a threat. So what do you do with a body that's still preparing for a famine that ended before the pyramids were built? You stop fighting it as if it were the enemy. Understanding where the impulse comes from doesn't make it disappear, but it does change what it means when it shows up. The goal was never to silence 2 million years of survival programming through sheer force of will. Every culture that has managed to build a healthy relationship with food has done it by working with these ancient signals, not against them, eating with rhythm and regularity, staying attuned to fullness instead of racing past it, treating hunger as information rather than an emergency to be crushed. You stop treating your cravings as weakness. You start treating them as evidence. Evidence of just how effective your ancestors' survival strategy was. Evidence of a system so well built that it outlived the very conditions that created it. Every time your stomach growls an hour after lunch, every time you find yourself standing in front of an open fridge for no clear reason, you are watching 100,000 generations of hunger distilled into a single, quiet impulse. There's something almost humbling in that. You are not broken. You are ancient. Every craving is a message sent from a body that has never once forgotten what it means to almost not survive. So tonight, when you finish dinner and still find yourself eyeing something sweet in the cupboard, remember what's actually happening. That's not a lack of discipline talking. That's the echo of a famine that ended 11,000 years ago, still running quietly in the background, still trying, in its own outdated way, to keep you alive.